The six main types of reactions discussed in this video are synthesis, decomposition, single replacement, double replacement, redox, and neutralization. A synthesis reaction occurs when two or more reactants combine to form a single product. A synthesis reaction can be represented by the general equation A plus B yields AB. In this equation, the letters A and B represent the reactants that begin the reaction, and the letters AB represent the product that is synthesized in the reaction. An example of a synthesis reaction is the combination of hydrogen and oxygen to produce water, or sodium and chloride to produce sodium chloride. The equations for the reactions are shown above. A decomposition reaction occurs when one reactant breaks down into two or more products. A decomposition reaction can be represented by the general equation AB yields A plus B. In this equation, AB represents the reactant that begins the reaction, and A and B represent the products of the reaction. Examples of decomposition reactions include the breakdown of hydrogen peroxide to water and oxygen, and the breakdown of water to hydrogen and oxygen. A single replacement reaction occurs when one element replaces another in a single compound. A single replacement reaction has the general equation A plus BC yields AC plus B, or A plus BC yields BA plus C. In the equation A plus BC yields AC plus B, A represents a pure element and BC represents the original compound. During the reaction, A replaces B, forming the product compound AC and releasing the pure element B, and is the same for A plus BC yields BA plus C. A double replacement reaction occurs when the positive and negative ions of two ionic compounds exchange places to form two new compounds. This reaction can be distinguished as the reaction that exchanges elements. A double replacement reaction can be represented by the general equation AB plus CD yields AD plus CB. AB and CD are two reacting compounds, and AD and CB are the two product compounds that result from the reaction. During the reaction, the ions B and D change places. A redox reaction, or oxidation-reduction reaction, is a reaction that involves the full or partial transfer of electrons from one reactant to another. A redox reaction is composed of oxidation and reduction. Oxidation is the full or partial loss of electrons or the gains of oxygen. Reduction is the full or partial gain of electrons or the loss of oxygen. When determining what is being oxidized or what is being reduced in an equation, you use OIL rig. OIL stands for oxidation is losing electrons, and rig stands for reduction is gaining electrons. Oxidation and reduction reactions can be shown in a separate equation called a half reaction. A half reaction is an equation that shows either the oxidation or the reduction reaction that occurs during a redox reaction. It is important to remember that the two half reactions occur simultaneously. The resulting ions that are formed are then attracted to one another in an ionic bond. Neutralization reaction, or acid-base reaction, is a reaction in which an acid reacts with a base to produce salt and water. In an acid-base reaction, the salt is not always NaCl. An easy way to remember a neutralization reaction is acid plus base makes salt and water, where water is always one product and a salt is also produced. The salt is a neutral ionic compound. Hydrogen is included with the acid, and hydroxide is included with the base.